The last part of chapter 1 number systems is 1.5, which is laws of exponents. In this chapter, we will be learning how to simplify the given expressions using different laws of exponents. Let us take a look at laws of exponents for real numbers. So if you can see numbers such as a power m or a power n, here we call a as a base and m and n as powers or exponents. The first law of exponents states that if a power m into a power n is given, it can be written as a power m by m plus n. So here we can see that with the same base and different exponents, we can just add the exponents. Let us take a look at an example. 7 power 5 into 7 power 2, right? We can write as 7 power 5 plus 2. So when the base is same and its multiplication, you have to add the exponents. We get 7 power 7. Second law of exponent states that if you have a base to the power of something and to the power of something, that is if you have two exponents, then you can multiply these exponents. So with a single base and two exponents on top of each other can be multiplied. Example is 8 square to the power of 8 can be written as 8 power 2 into 8, which is 8 power 16. The third law of exponents states that with the same base in division with different exponents, the exponents can be subtracted. So for example, 6 power 5 by 6 can be written as 6 power 5 minus 1, which is equal to 6 power 4. Fourth law of exponents states that if we have two different bases but the same exponent of power, you can multiply the two bases to that particular power. So 3 square into 6 square can be written as 3 into 6 whole square, which is 18 square. Fifth law of exponents is that anything to the power of 0 will be equal to 1. It can be 2 power 0 or 100 power 0, it's going to be equal to 1 as long as the exponent is 0. The last law of exponent states that 1 by a power n equals to a power minus n. So for example, 1 by 5 cube can be written as 5 power minus 3. Let us solve exercise 1.5 questions using the laws of exponents that we just learned. So the first question asks us to find 64 power 1 by 2. How do we simplify this? In order to simplify questions like this, you can take the help of the list of perfect squares, perfect cubes and so on. For example, in perfect squares, especially because I have a power 1 by 2 here, I'm looking at 64 which also has a power of 2. So I can see 8 square is 64. I'm going to write this as 8 square power 1 by 2. Now using the law a power m whole power n equals to a power m into n, I can do 8 power 2 into 1 by 2. So this 2 and 2 gets cancelled. I'm left with 8 power 1, which is nothing but 8. Second question is 32 power 1 by 5. Now remember, because there is 5 here, you have to think of a number that might have a power 5 which is equal to 32. Now I know that 2 power 5 is equal to 32. So I can write 2 power 5 into 1 by 5. Similar to this question, I can cancel 5 and 5. I'll be left with 2 power 1, which will be equal to 2. Third question is 125 power 1 by 3. Again, I have to think of a number whose cube, that is whose power to 3 will be 125. So I know that 5 power 3 is 125. So I can write 5 cube power 1 by 3 and 3 and 3 will get cancelled. I'll be left with 5 power 1, which is equal to 5. We can see similar problems in the second question, with the first one saying simplify or find 9 power 3 by 2. Again, focus on the denominator and try to find a number whose square is 9, because we have 2 here. So I know 3 square is 9, so I can write 3 power 2 whole power 3 by 2. Now I can cancel this 2 and 2. So 3 cube can be written as 3 into 3 into 3. The answer is 3 3s are 9, 9 3s are 27. The second question is 32 power 2 by 5. We just saw that 2 power 5 was 32. So I can write 2 power 5 whole power 2 by 5, right? So 5 and 5 will get cancelled. I'll be left with 2 square. We know 2 square is 2 into 2, which is 4. The third one is 16 power 3 by 4. So we have 4 in the denominator here. So it's better to think of a number that has a power 4 equal to 16. Now 2 power 4 is equal to 16. So 2 power 4 whole power 3 by 4. I can just cancel 4 and 4. I'll be left with 2 cube, which is 2 into 2 into 2. 2 2s are 4, 4 2s are 8. Fourth one is 125 power minus 1 by 3. Now we have 3 in the denominator. Think of a number whose cube is 125. 5 cube is 125. So 5 cube whole power 1 by 3. 3 and 3 gets cancelled. 5 power 1. We know that a power minus m equals to 1 by a power m, right? So 5 power minus 1 is 1 by 5. In third question, we have slightly complicated version of what we just did. So they have given us 2 power 2 by 3 into 2 power 1 by 5. So remember the identity a power m into a power n. So what we have to do, we have to add the exponents here. So 2 power 2 by 3 plus 1 by 5. How do we add fractions? We take LCM, which is 15. So 2 into 5 is 10, 3 into 1 is 3. So 2 power 10 plus 3 is 13 and we are left with 15. So the answer is 2 power 13 by 15. Second question is 1 by 3 cube whole power 7. So in this case, the power is for both 1 and 3 cube. 1 power 7 by 3 cube whole power 7. 1 by, in the denominator we have a power m into n, that is 3 into 7 is 21, which can also be written as 3 power minus 21 because of this rule. Third question is 11 power 1 by 2 by 11 power 1 by 4. Here we have a common base, that is 11. However, the exponents are differing. So by this rule, a power m by a power n we can write as a power m minus n. So 11 power 1 by 2 minus 1 by 4. Again taking LCM, 2 2s are 4. 1 is just like we have 4 here. So 1, 2 minus 1 by 4, which is 1 by 4. The answer is 11 power 1 by 4. The last question, 7 power 1 by 2 into 8 power 1 by 2. Here we have different bases but same exponents. What do we do in this case? A power m into b power m equals to a into b whole power m. So we can multiply the base first and give the power to the whole thing. So 7 into 8 whole power 1 by 2 can be written as 56 power 1 by 2. This can also be written as we have another rule, which is a power 1 by m is nothing but m root of a. So here m equals to 2 in this case. So I can write it as square root of 56. That is the end of chapter 1.